Alright, so we're going to be doing question 1 for the McGraw-Hill assignment from chapter 9. So consider a population having a standard deviation equal to 10.06. We wish to estimate the mean of this population. So the first question A, how large a random sample is needed to construct a 95% confidence interval for the mean of this population with a margin of error equal to 1. Round your answer to the next whole number. So the first step is to write our knowns. So over here, we know that the z-score of 95% confidence interval is always going to be equal to 1.96. This can be seen in the introductory course, in the introductory YouTube video, or you can just find the z-score yourself. The standard deviation is given to us, which is 10.06. The margin of error is given to us, which is equal to 1, and we want to find our n, which is the sample size. So step 2, use the n formula to find our sample, which is n. So n is equal to this formula over here. And so once you plug our z in, this is just pretty much z times standard deviation and divided by our margin of error e, which is equal to 1, and then we just so we square it, so then n is equal to 389. So that's our sample size. So now b, suppose that we now take a random sample of the size we have determined in part A, so 389. If we obtain a sample mean equal to 291, calculate the 95% confidence interval for the population mean. What is the interval's margin of error? Round your answer to the nearest number. So step 1 is to write our knowns like every other problem. So we know that our sample size is 389. Our x bar that the just gave us, which is 291 right here. 291 right here. Our z-score is still 196 because of the 95% confidence interval. Our confidence interval percentage is 95%. Our margin of error, we do not know. They want us to calculate that with our x bar, and they want us to calculate a confidence interval with a lower and upper limit. So let me just highlight in yellow. These are the things that we need to find. So step 2, find the margin of error. So we're going to be using this formula here. Let me highlight that, and I'll highlight it in green. So this is the formula we need to use. So once we plug it in our numbers, e is equal to 1.96 times 10.06 divided by the square root of n, which is 389. So that gives us 0.99, and since it tells us to round to the nearest number, we're going to round it to 1. Step 3, find confidence interval. So this is right here. We're going to be using this formula. I'll put it in green like the other one. So we're going to be using this formula. And so once you do that, so our x bar is 291 plus, so for upper limit we're going to be doing plus, and for lower limit we're going to be doing minus. So that's why you could see right here where my cursor is, there's a plus or minus, because depending on the upper limit it's a plus, lower limit it's a minus. So x bar of 291, so go into your calculator, 291 plus 1.96 for the z-score times, well, pretty much, let me do this in blue. This, here, let me erase the green. And so what's in blue here is what we've already calculated, and if you guys already know, this should be your margin of error right up here. So this is the green. This and this are the exact same formula. So it's pretty much just 291 plus, for upper limit, plus 1, or margin of error, which is 292 right here. Let me highlight that, 292. And then our lower limit, which is minus, so 291 minus 1 right here, 290. So there's our answer. Our confidence interval is 290 to 292.